Today we will discuss about conformal low power. And yesterday we also discussed about the physical verification. So this physical verification is meant to check with respect to your routes whether you are following the design rules, so which was provided by your vendor. Okay, now I didn't capture much slides, just we will finish early today. So other we will discuss something if you have any doubts. Okay, so first, Ali, you just try to understand that conformal low power is short form called as CLP. Okay, so you had to go for the sign of check when there are power domain crossings. So I explained to them about low power design. Okay, I will recall that one. Okay, is moreover it is there. Okay, now if your design is operating, if your design is operating with your design is operating with a different domain, I will let you know what is domain. Suppose generally our design is in this shape. It is a square or it is a rectangle. Suppose if your operating voltage is 1 volt, so every cell in this in every cell in the design has to operate by 1 volt. But there is some logic which doesn't require 1 volt, so it may require zero point 0.9 volt. So some design here logic may require 0.75 volt. So this part we are going to say as domain, voltage domain. So in this part of the cells, we will place at one location and will give one more domain name. And this part is 1 volt. This part may 1.1 volt. So why we are going to differentiate these type of domains is to reduce your power consumption. So the basic intention to create these multiple domains is to reduce power consumption. Suppose if this part of the cell is operating zero point 0.9, if you're giving 1 volt, so then that is no use, right? The same way. So we will group these types of cells and we will divide into power domains. Generally, these are power domains. Okay, suppose if you see, this I have captured from internet. So if you see this one, it has named as alpha, beta, and gamma. If you observe this, operating voltage of this device is 2 volt, and operating of this voltage is defined as 1 volt, and the gamma voltage is defined as 3 volt. And if you cleanly observe that, it was indicated as always on. Okay, so before to go for always on, so there is on off domain and always on domain. Suppose if I say, so if you say on off domain, this one. Okay, this sometimes this domain is in on state, and it if it not required the working of this one. Suppose if you are operating a mixer in your home, if when you're it when it is not required, you are going to turn off. When it is required, you are going to turn it on. The same way, when it is in use, it goes in on state. When it is not in use, to save that power, there is a two powers. I said static power and the dynamic power. So to save this dynamic power, simply remember that to reduce the power consumption, we are going whenever this domain is not in use, we are going to turn it off. Suppose a best example, So there is no requirement of light in your room during the daytime. Okay, so if you turn it on, if there is no requirement, then the power consumption is more. Okay, so which leads to some other issue, I mean, like your power bill, current bill, that's why. So when it is not in use, you're going to turn it off. The same way, so when the device is not in use, you're going to off it. When the device is going to work, then you're going to make it on. So there are two types of domains. One is on off domain, one is completely on. Completely on send that on means this device is always in active state. Okay, now the thing is that you have to understand what is this CLP. If you observe these two things, Ali, I'm just especially I'm saying to you, there are different cells. We have different cells. One is isolation cell, level shifter, and retention cell, and power switches. So these are low power cells. Why we are going to use these low power cells is to get proper communication between one domain to another domain and one domain to other domain. So the communication should happen within this domain, because the logic present in this domain may communicate to the logic present in beta domain, and similarly there is some logic between beta and gamma. Okay, this will happen mostly. There is a communication between domains. Now if you observe here, this operating voltage is 2 volts, and think that this operating voltage is 1 volt. So now the highest voltage, suppose a logic, there is a logic AND gate, and this AND gate is communicating some OR gate here. Now what happened, this cell operating is at 1 volt, but this cell operating at 2 volt. Now there is a voltage difference between these two cells. Then what you have to do, the proper logic which is coming from this cell may not get the proper value to this cell. So such that in order in this way, vice versa, and also vice versa, 1 volt, if the 1 volt cell is communicating some other cell somewhere here, the logic may not be same because of voltage swing or voltage difference. So to avoid this, we have level shifters, isolation, and retention. And coming to the level shifter, we have low and high level shifter. Okay, low level shifter or low to high level shifter. Okay, and high to low level shifter. LS indicates level shifter. Now, so if there is a difference, suppose this cell 2 volt has to interact with this cell. So 2 volt is your design value, and this is operating at 1 volt. So 2 volt has to be converted into 1 volt. So high voltage is converted with the low voltage by using low level shifter. And suppose one of the cell here is going to communicate to the gamma domain, then this operating voltage is 1 and this is 3. So there is a voltage difference between these two domains. Now a low voltage cell, when it want to logically connect to 3 volts, there is a since there is a voltage difference, it may not get proper logic. Okay, then what we use low to high level shifter. So these I mean, from one domain conversion to another domain with respect to voltage, we have low level shifter. Coming to the isolation and retention cell, so what happens to the so this is related to, if you observe here, it's, I already said that this is on off domain. Okay, this is on domain. So the cells present in this domain is always active. Suppose there is a communication of one cell. There is one cell is communicating. So now there is a one cell here, and there is one more cell here. Now, since it is in active state, so whatever the data getting, it's immediately received, will go to this one. If these two are logically connected, some data which is coming from this cell will go to this cell, but still, I mean, this is in off state. So off state, nothing but it will not take this input. So what happens then? Some unwanted data will may get this into this cell, and the data I mean, the whatever the logic will go wrongly. So then what happens, right? There is a retention cell. There is a retention cell between these two domains, that whenever this device is turned on, so this the whatever the data present here, it will move to retention cell. So this retention cell will store the data. When this device get turned on, immediately the data is moved here, such that you are getting, I mean, the data may not be corrupted. This is called retention cell. And isolation cell is also similar. It will clamp nothing but it will hold for some time. The data will hold for some time. So this way we have three different cells. Now coming to other cell is called power switches. Power switches nothing but, since it is off and on, no, if it is on, no problem. If it goes off, that is also no problem. But immediately the off will not go into on state. So there is some power switches. So these power switch, I mean, so I mean, if you turn off your fan, so when you turn on your fan, immediately your fan will get on. But when you turn off your fan, turn off your fan will not turn off immediately, nothing but it will go for the slow rotation, and then at some point it will off the same way. So because of because of this, some logic may corrupt. To avoid that, we are going to use always on cells. You're able to see the screen, right? Right. So what happens when there are some regular intervals? We will place some regular intervals in your on off domain like this, equal intervals. So this fashion, I mean, if you okay, let me draw here. So if it is off on domain, so your cells will sit like this. In regular intervals, it will sit in this fashion is called checkerboard. Checkerboard is nothing but like a chessboard. This is also called as daisy, mother chain, mother and child fashion also. Okay, this way we will place power switches in regular intervals of design when your device is in on-off state. Okay, then when device goes into off state, these cells are active and will supply power to these cells present in this domain. So this way we will define four different cells when you are going for low power design. Now thing is that if you actually the CLP, the main CLP issue is, now this device is off. So there, if you go, if you want to add a cell to fix a timing, so there is a always on buffer cell. Always, I mean, buffer, always on buffer cell, nothing but it is a buffer. This is a buffer. There is extra input. There is a third terminal called on off. This is for always on. There is an extra terminal called external pin. So this external pin makes this buffer always on. Okay. So when you want to communicate these two domains, tool will try to add always on cells. If tool will try to add a normal buffer, then there exists a CLP issue. So during this power domain crossing, you have to check which always, I mean between the always on, between on off domain, you have to add a proper buffer. So you have to decide whether this buffer is always on or it's a normal buffer. If instead of adding a non always on buffer, with a normal buffer, then it causes a CLP issue. So that I have catched here. So if there is a domain crossing from on to off to on state, then you need to add one isolation cell with a proper control signal and clamp value. If you are not able to add this one, it leads to some logic change or logical disparity that leads to CLP issue. And other also I have catched, this you will understand when you try to implement this one. Okay, then the next one which we are going for ESG. So I already explained this ESG one time, but I have just mentioned the ESG. You can read this one. Okay, so if you observe that, your device, this is your device. So, okay, let me give one real example. Now, you turn your TV on and your electronic appliances is on. Suddenly, there is a lightning, I mean, more lightning outside. Your weather condition is very bad. So, because of thunder sounds, that what happens, your device, I mean, because of this environmental change, since your device is in work state, so because of the high thunder sounds, your device may get, I mean, what, spoil, or I can say that breakdown. Okay, the same way, since you're going for the lower technology node, so you have lot of logic present in the device. And because of sudden charge flows, I mean, so I given best example, right? When you suddenly hit somewhere to your, I mean, to the surface of your hand, suddenly you will get the some shake in your hand. The same way, when something happened to device, it leads to charge flow. So this extra charge flow will create some extra unwanted potential. So since your gate is very lightly doped, I mean moderately doped, it may defect or it may spoil your gate of your CMOS device. So that's why to avoid these conditions before going to manufacture, we are going to add some extra cells called ESD cells. ESD stands for electrostatic discharge. Whatever the charge which was accumulated due to difference in potential, that will get discharged when it placed. So generally, if you see there, this is my design. Generally, SOC team, they will only say that. So this is more operating and more logic is required here. Then we need to add one ESD cell like this. So how to add an ESD cell? Nothing but, so whatever the operating voltage, generally this, if this cell is working for VDD1, this is VDD2, VDD3, then you have to connect these ESD to VDD1 and the ground. So this is about ESD. So if you see the charged body touch an IC, suddenly when some charged body touches your IC, it will create some potential difference. It will destroy your device, because you're going to operate, I mean, we are going to construct a device in low power mode, nothing but lower voltage. Suppose because of this charge disturbances, the device voltage may change to higher value, which will spoil your machine and nothing but your design. So I just captured this one: a charged body touch and IC nothing but integrated charge, integrated circuit. A charged touch to ground surface, it may happen due to ground also, to some machine, some electrical machine, and a high electrical field, like now thundering to your TV. I mean, if sudden thunder happened or lightning happened, then your, how your TV gets spoiled, now the same way your device gets spoiled with the high electricity. So these are the ways which will create more charge. So to avoid this, we are going to place an ESD cell in your chip. Generally 1 2 cells based on your area. So now my area in my design is 1.1 square. So I'm just added two ESDs. One is with this location, one this one, and one this one. So in this way, we have to decide how many ESDs has to be added. This has to be added during your floor plan itself. It's like a macro. ESD is like a macro. So you have to add. It's like a analog macro. So you have to add ESD during the floor plan, and then you have to place your standard cell. You understand this one? Just please confirm. So ESD is some internal topic to your industry. Guys, please confirm if you understand or not.
Yes, ma'am.
Then we'll go for engineering change order. So what this engineering change order? So generally we call it as ECO. Even I'm not aware of complete definition. If the name indicates engineering change order, nothing but you're going to change the order. So what exactly this? Okay, so it is not. Suppose the think that there is a chip, or you designed a chip. So the you're getting some. I mean, from the physical design, you're getting a layout. So this layout should have minimal disturbances for this existing design. Okay, so if you implement some design, so for this design, so there should not be more disturbances, nothing but timing, with respect to timing only. Now there is a lot of timing issues, but once your layout, I mean, it is good enough. If it layout is good enough, but still you're seeing some timing issues, then we have to change that one. That is called engineering change order. I have captured the flow chart, so this is not required. So you have two types of, I mean, when you, okay, let me explain what is first tape out. So generally tape out nothing but you're the end of the design. Okay, if I say tape out, so tape out is end of the design. This tape out will go into two steps. One is uh, BTO, base tape out. One is metal tape out. Or I can say that if you see here the last line, freeze silicon. Silicon is getting freezed. Okay, I will explain you these two things during the tool. Now, what happens? Suppose there is a timing fix. So first thing is that first thing, timing ECO, functional ECO. You remember that base tape out, metal tape out, and then timing ECO, functional ECO. So what does timing ECO do? Timing ECO will do. So there is a setup is not met and your hold is not met. Once you got a layout, now you have to meet this setup and hold by adding some cells into your design. That cells are either buffer or an inverter. If you want to add an inverter, you have to add two inverters because logic should not change. So buffer and inverter you have to add during ECO to fix your timing. Okay, if you're doing adding of the cells in your design, that is called timing ECO. If you are playing with the metals instead of adding cells, that is called functional ECO or metal ECO. Okay, now suppose there is a one two flops like this. So there is a timing failure between these two paths. Then you will add a buffer in data path, or you can increase your drive strength, or you can change your LVT. I said na LVT, SVT, and you have different methods to fix the setup. You have different methods to fix the hole. So you have to choose the best one, and you have to fix here. This fix will go in ECO. Okay. So now your timing is good, but still timing there is small mismatch, setup mismatch, or max strand, max step violation. Now instead of adding, I mean, suppose your cell is freezed, no, you should not add your cells, standard cells like buffer or inverter. So then what you had to do, you had to play with the metals. Metal nothing but routes. So when you are going to play with the route, then that is called, I mean, once your base is fixed, base tape out is freezed, then you have to play with the metals, that is called metal tape out. Now, so you should not add any cells to this one. So how you are going to fix this one? By using metal. You are going to reroute that one, and if reroute will change your time, even reroute will change your timing. Suppose, for example, now this clock pin is getting delayed. Now, if your clock, suppose that there is a cell here, this is a long route. Now, what you have to do? You have to make some metal zigzag, and you have to fix this way. So when once you are playing with a metal or route, then that is called metal tape out. So this is one thing. If you see, this is functional ECO and this is metal ECO. This you will not understand now. Don't, I mean, don't by heart this one. Simply I captured one. Generally, you have ECOs are two types. Timing ECOs, functional ECOs. Timing ECOs, we can add a cell. Functional ECO, we have to play with the metals. So suppose if there is a necessity to add a cell, then what you do, right? We have programmable filler cell. So this was placed during your layout. I mean, once your design is freeze, so there are empty spaces in your design. So these empty spaces has to be filled with filler cells, which we discussed during physical cells. Okay. So now there is a small. This is your area. All logical cells has been placed, but some area there are empty spaces. So during manufacture, so when you go for ultraviolet UV radiation or any other thing, so this empty cell, empty gap will leads to some issues. So to avoid that, we will add a filler cells. So there are normal fillers, there are programmable filler cells. So what this then during metal ECO, if you want to add some cell, then what we do, right? This we will convert this programmable filler cell into the required. I mean, if you understand this programmable cell is 2x cell, then we will convert this 2x dry cell into the buffer. So in this way, we will convert these programmable fillers into the logical buffers. Then we will fix the timing. So this is one of these, also called as space cells. Space cells or programmable fillers are both the same. We will include these cells during your before to base tape out. So these cells will help us in this way, that it will convert automatically. There is a specific script for that, which will convert these programmable filler cells into buffers as per your logic, and we will fix the timing by using this. So if you go on search in YouTube, you will find some post mask, pre mask that is not required. Just you remember that we have different types of ECOs: timing ECO, metal ECO. Even this timing ECO well divided into power ECO and clock ECO also, but mostly two ECOs: timing, metal. You understand this one?
మేడం ఒకసారి తెలుగులో చెప్పరా ఈసీఓ గురించి?
Okay. Ali,
టైప్
okay. Uh, Ali, I'm just telling in Telugu for them. Saira, you can stop sharing. Uh, మనకి టైమింగ్ ఫిక్స్ అవ్వదు ఎడుకొండలు. మన మన లేఅవుట్ పోస్ట్ రౌట్ తర్వాత ఇంకా కొన్ని టైమింగ్ వయలేషన్స్ ఉన్నాయనుకో, కొన్ని టైమింగ్ బగ్స్ కానీ అదే బగ్స్ కానీ టైమింగ్ వయలేషన్స్ ఉన్నప్పుడు మనం ఏం చేస్తామంటే కొన్ని బఫర్స్ని బఫర్స్ కానీ డిలే బఫర్స్ కానీ ఈ టైం ఫిక్స్ చేయడానికి ఈ టైమింగ్ ఫిక్స్ చేయడానికి మనం యాడ్ చేస్తాం. ఈ
సెటప్ వాయిస్ కదా మేము బఫర్స్ యూజ్ చేసేది.
సెటప్ అవ్వచ్చు, హోల్డ్ అవ్వచ్చు, మ్యాక్స్ ఫ్యాన్ అవ్వచ్చు, ఫ్యాన్ అవుట్ అవ్వచ్చు, క్యాప్ అయినా అవ్వచ్చు. ఏదైనా ఇవి టైమింగ్ వయలేషన్స్. ఇవి ఫిక్స్ చేయడానికి మనం ఎక్కడైతే అవసరమో అక్కడ
వాయిస్ ఒక
ఇప్పుడు
బ్రేక్.
వినపడుతుందా? వేడికొండలు ఇప్పుడు వినపడుతుందా? నేను స్టాప్ చేశాను బెటర్ వాయిస్ కోసం. ఇప్పుడు ఈ టైమింగ్ వయలేషన్స్ ని ఫిక్స్ చేయడానికి ఒక స్పెసిఫిక్ ఫ్లోని మనం ఇంటిగ్రేట్ చేసుకున్నాం. ఆ స్పెసిఫిక్ ఫ్లోని ఏమంటామంటే ఈసీఓ అంటాం, ఇంజనీరింగ్ చేంజ్ ఆర్డర్. ఇది ఏంటంటే లాస్ట్ మినిట్ చేంజెస్ ఇన్ అవర్ డిజైన్. ఓకే, సో దీని వల్ల ఏమవుతుందంటే ఈసీఓ మనకి ఏమవుతుందంటే ఇట్ విల్ సేవ్స్ యువర్ మనీ అండ్ ద టైమ్ అండ్ ఇట్ ప్రివెంట్ ద ఇష్యూస్ విచ్ ఆర్ క్రియేటింగ్ డ్యూరింగ్ మ్యానుఫ్యాక్చర్. ఓకే, ఇప్పుడు జనరల్గా ఏం జరుగుతుందంటే మనకి పోస్ట్ రౌట్ నుంచి ఒక నెట్ లిస్ట్ వస్తుంది. ఈ నెట్ లిస్ట్ యూస్ చేసుకొని మనకి ఎక్కడైతే టైమింగ్ ఫిక్సెస్ అవ్వదో అక్కడ బఫర్స్ కానీ డిలే బఫర్స్ కానీ మనం యాడ్ చేయాలి. ఓకే, సో దీన్ని ఏ స్టేజ్ అంటామంటే బిఫోర్ టు టేప్ అవుట్ అంటాం. టేప్ అవుట్ అనేది ఫైనల్ పార్ట్ అన్నమాట. ఓకే, ఇప్పుడు ఇక్కడ ఈసీఓలో ఏం చేస్తాం, నువ్వు ఆ ఫిక్స్ చేయడానికి యాడ్ అయినా చేయొచ్చు, డెలీట్ అయినా చేయొచ్చు. యాడింగ్ ఆర్ డెలీటింగ్ ద సెల్, అప్డేటింగ్. సో తర్వాత అప్డేటింగ్ ద కనెక్షన్స్ అంటే అప్డేటింగ్ యువర్ నెట్ రౌట్స్. అంటే ఒకవేళ లాంగ్ రౌట్ ఉందనుకో, ఆ లాంగ్ రౌట్ వల్ల నీకు నాయిస్ కానీ యాంటీనా కానీ వస్తున్నప్పుడు ఏం చేయొచ్చు అంటే దానికి ఎగ్జిస్టింగ్ సెల్స్ అన్నా యాడ్ చేయొచ్చు, ఆ రౌట్ ని మనం రీరౌట్ అన్నా చేయొచ్చు. ఒకవేళ ఒక ప్లేస్మెంట్ ప్రాపర్ గా లేదు, సో ఆ ప్లేస్మెంట్ ని కూడా మనం మూవ్ చేయొచ్చు, రౌటింగ్ చేయొచ్చు, డెలీట్ చేయొచ్చు, యాడ్ చేయొచ్చు, కనెక్షన్స్ ని అప్డేట్ చేసుకోవచ్చు. సో వీటిని అన్నిటిని ఏమంటామంటే ఈసీఓస్ అంటాం. యు ఆర్ గోయింగ్ టు చేంజ్ ద ఆర్డర్. ఓకే, సో జనరల్ గా మనకి ఈసీఓస్ యాడ్ చేయడానికి డిఫరెంట్ కమాండ్స్ ఉంటాయి. ఒకవేళ ఇప్పుడు FC టూల్ అయితే ఈసీఓ సెల్ అని ఉంటది. అదే ఇన్నోవస్ అయితే యాడ్ ఈసీఓ ఇన్సెట్ బఫర్ ఉంటుంది. దేనికి ఫ్యూజన్ కంపైలర్ కానీ ICC2 కానీ ఇన్సెట్ బఫర్ అనే కమాండ్ ఉంటుంది. ఒకవేళ ఇన్నోవస్కి వెళ్తే ఈసీఓ యాడ్ రిపీటర్ అని ఉంటది. సో మనం ఈ డిఫరెంట్ కమాండ్స్ యూస్, ఎందుకంటే డిజైన్ ఫ్రీజ్ చేసేసాం, పోస్ట్ రౌట్ లో డిజైన్ ఫ్రీజ్ చేసాం, కానీ కొన్ని టైమింగ్ వయలేషన్స్ వస్తాయి. ఎందుకంటే మనం డిఫరెంట్ కార్నర్స్ లో రన్ చేస్తాం. మనము పోస్ట్ రౌట్ వచ్చేసి కొన్ని కార్నర్స్ లో రన్ చేస్తాం, కానీ ఈసీఓ ఈ ఫైనల్ సైన్ ఆఫ్ కి వెళ్ళేటప్పుడు చాలా కార్నర్స్ లో రన్ చేస్తాం. చాలా కార్నర్స్ రన్ చేసినప్పుడు టైమింగ్ వయలేషన్స్ అనేది ఉండొచ్చు. అప్పుడు ఏం చేయాలంటే అది ఫ్రీజ్ చేసింది మనం మళ్ళీ ఓపెన్ చేయడం ఎందుకని ఒక ఈసీఓ కమాండ్స్ యూస్ చేసి అక్కడ ఒక స్పెసిఫిక్ సెల్స్ ని యాడ్ చేస్తాం. ఇప్పుడు కొన్ని సెల్స్ అన్ని స్పేస్ చేసిన తర్వాత వేరే ఒక కార్నర్ లో రన్ చేసినప్పుడు మళ్ళీ ఆ ఇష్యూస్ వచ్చినాయి అనుకో, అప్పుడు దాన్ని ఏమంటామంటే అప్పుడు రౌట్స్ తో ప్లే చేస్తాం. దాన్ని ఏమంటామంటే మెటల్ టేప్ అవుట్ అంటాం. అంటే బేస్ ని ఫిక్స్ చేస్తాం. బేస్ టేప్ అవుట్ అంటే ఇంకా సెల్స్ ని యాడ్ చేయకూడదు. వాట్ ఈస్ బేస్ టేప్ అవుట్ అంటే సెల్స్ ని అస్సలు యాడ్ చేయకూడదు అనమాట. మెటల్ టేప్ అవుట్ అంటే ఏంటంటే ఫస్ట్ బీటీఓ జరుగుతుంది. ఓకే, ఫస్ట్ బీటీఓ తర్వాత ఎంటీఓ. సో ఇప్పుడు బేస్ లేయర్ ని టచ్ చేయదు. బేస్ లేయర్స్ అంటే ఏంటి, స్టాండర్డ్ సెల్స్ అంటే ఏంటి, సమ్ లాజిక్ లైక్ బఫర్ ఇన్వర్టర్స్. ఇది నువ్వు ఫ్రీజ్ చేసిన తర్వాత నువ్వు మళ్ళీ ఆ సిలికాన్ ని టచ్ చేయకూడదు. మరి ఇప్పుడు ఎలా టచ్ చేయాలి, నువ్వు ఏం టచ్ చేయాలి అంటే ఓన్లీ మెటల్స్ ని టచ్ చేయాలి. ఫస్ట్ బేస్ ని ఫిక్స్, మనకి ఎలా జరుగుతుంది అంటే ఫ్యాబ్రికేషన్ ఫస్ట్ ని బేస్ ని ఫిక్స్ చేస్తాం. ఓకే, ఫస్ట్ బేస్ ని ఫిక్స్ చేసిన తర్వాత బేస్ ని ఫ్యాబ్రికేట్ చేసిన తర్వాతనే మెటల్ 1 ఫ్యాబ్రికేట్ అవుతుంది, తర్వాత మెటల్ 2 ఫ్యాబ్రికేట్ అవుతుంది, తర్వాత మెటల్ 3 ఫ్యాబ్రికేట్ అవుతుంది. ఇప్పుడు నువ్వు బేస్ ని ఫ్యాబ్రికేట్ అయిన తర్వాత నువ్వు బేస్ ని టచ్ చేయవు కాబట్టి, సో నువ్వు దేన్ని టచ్ చేయాలి, మెటల్స్ ని టచ్ చేయాలి. సో అప్పుడు నువ్వు ఏం చేస్తావంటే మెటల్స్ తో ప్లే చేస్తావు. దాన్ని మెటల్ టేప్ అవుట్ అంటాం. అర్థమైందా? పర్వాలేదు చెప్పు, ఇంకా
Yes,
అర్థం
madam.
అవ్వకపోతే చెప్తాను.
అర్థం కాలేదు మేడం. అదే మెటీరియల్ ఒకసారి చెప్పండి మేడం. మెటీరియల్ కొంచెం కన్ఫ్యూజ్ అవుతుంది.
ఓకే, ఫస్ట్ నేను
Material.
చెప్తా విను. టేప్ అవుట్ అనేది మనకు, టేప్ అవుట్ అనేది ఫైనల్ స్టేజ్. ఇట్స్ ఫైనల్ స్టేజ్ ఆఫ్ యువర్ డిజైన్ ఆర్ ఇంటిగ్రేటెడ్ సర్క్యూట్. ఓకే, ఐ మీన్ ఇట్స్ బిఫోర్ టు సెండ్ టు ద మ్యానుఫ్యాక్చర్. అంటే ఆ డివైస్ మన మ్యానుఫ్యాక్చరింగ్ కి పంపించే ముందు జరిగే ప్రాసెస్ ని టేప్ అవుట్ అంటారు. టేప్ అవుట్ ఈజ్ అ ఫైనల్ స్టెప్ ఆఫ్ యువర్ డిజైన్ ఆఫ్ ఇంటిగ్రేటెడ్ సర్క్యూట్. సో బిఫోర్ సెండింగ్ టు యువర్ ఫ్యాబ్రికేషన్ యూనిట్. సో ఇది ఇప్పుడు ఇక్కడ మనకి ఏం జరుగుతుందంటే, ఇక్కడ ఏదైనా ఇష్యూస్ ఉంటే యూ కెన్ ఫిక్స్ దట్ బగ్, యూ కెన్ ఫిక్స్ దట్ ఎర్రర్. అది జరిగేది 2 ప్రాసెస్ లో ఉంటది. బేస్ టేప్ అవుట్, మెటల్ టేప్ అవుట్. ఫస్ట్ జరిగేది ఏంటంటే బేస్ టేప్ అవుట్. బేస్ టైప్ అవుట్ అంటే ఏంటంటే, బేస్ అంటే కింద లాస్ట్. ఇప్పుడు బేస్ అంటే నీకు తెలుసు కదా, ద బాటమ్ ఆఫ్ ద డిజైన్. సో ఈ బేస్ లో అన్ని స్టాండర్డ్ సెల్స్ ఉంటాయి. ఇప్పుడు ఈ స్టాండర్డ్ సెల్స్ ని ఫ్రీజ్ చేయడం, దాన్ని బేస్ టైప్ అవుట్ అంటారు. ఇప్పుడు ఫ్రీజ్ చేయడం అంటే, ఒక బేస్ టేప్ అవుట్ ని స్టాండర్డ్ సెల్స్ ని ఫ్రీజ్ చేసినాం అంటే డిజైన్ లో ఎటువంటి సెల్స్ ని యాడ్ చేయం. ఓకే, మరి ఇప్పుడు యాడ్ చేయనప్పుడు ఆ ఫిక్స్ ఎలా ఫిక్స్ చేస్తావు? నీకు అక్కడ ఒక బగ్ ఉంది, ఒక ఎర్రర్ ఉంది, నువ్వు ఫిక్స్ చేయాలి. అది ఎలా ఫిక్స్ చేస్తామంటే, బై ప్లేయింగ్ విత్ మెటల్స్ అంటే రౌట్స్. నెట్స్ ఉంటాయని చెప్పిన కదా, డిఫరెంట్ టైప్స్ ఆఫ్ నెట్స్ ఉంటాయి కదా. ఆ నెట్స్ ని రీరౌట్ చేయడం కానీ, ఆ నెట్స్ ని ఇంక్రీజ్ చేయడం కానీ చేసి దాన్ని ఫిక్స్ చేస్తాం. అసలు ఫిక్స్ అవ్వకపోతే మనం మళ్ళీ ఓపెన్ చేస్తాం అనమాట. జనరల్ గా ఫిక్స్ అవుతుంది అనుకుండానే బేస్ ని ఫ్రీజ్ చేస్తాం. ఇప్పుడు అర్థమైందా?
ఎస్ మేడం, అర్థమైంది.
జనరల్ గా మన ఇప్పుడు క్వాల్కమ్, బ్రాడ్కామ్, సామ్సంగ్ లో టేప్ అవుట్స్ అంటారు. IBM లో వచ్చేసి రిట్ A, రిట్ B అంటాం. రిలీజ్ ఇంటర్ఫేస్ టేప్ రిట్ A అంటాం. అది వచ్చేసి నాన్ మెటాలిక్ స్ట్రక్చర్ బేస్. రిట్ B వచ్చేసి రిలీజ్ ఇంటర్ఫేస్ టేప్. B అంటే ఏంటంటే ప్లేయింగ్ విత్ యువర్ ప్యాటర్న్ జనరేషన్. మనకి డిఫరెంట్, ఇప్పుడు ఒకవేళ టెక్సాస్ టెక్సాస్ కంపెనీకి వెళ్ళాను అనుకో, వాళ్ళు ప్యాటర్న్ జనరేషన్ అంటారు. కంపెనీ టు కంపెనీ మారుతుంది, కానీ జనరల్ గా నామన్ క్లేచర్ మీనింగ్ అయితే ఒకటి, టేప్ అవుట్. ఓకే,
ఎస్ మేడం, అర్థమైంది.
శ్యామ్, యు అండర్స్టాండ్ శ్యామ్?
Yes, ma'am.
వాట్ అబౌట్ సాయి?
Yes, ma'am. Okay.
Ali, you have any doubts, Ali?
No, ma'am.
Okay, so if you have any questions, let me know. Any questions from your end, we'll discuss now. So most of theory part has finished. If you find any new terminology in then let me know. I will explain that one. Any questions, Ali, from you? Any questions, fine. If you don't understand now, let me know. You ask me, we'll clear the doubt. Shall we close the call, or shall we? If you want to ask the questions, we'll stay. If you're not, we'll close the call.
When tool will be provided, ma'am?
Yeah, tomorrow you just I mean, if you 3 are available tomorrow, you just inform Edukondalu and Sham Sai. So they are trying to install tool. Ganesh want to, I mean, interact with you over the call. So when you are free, 3, you just discuss in the team or in the group, and just be available in that time, and Saira will connect the call with the Ganesh. Because I had to go office and I will come from office at 7 o'clock. So tomorrow Ali, tell me.
Those tools only we are using in physical designing, no?
Generally, that is some platform. So over that VNC, you have to install your compiler. I think we are going for the Synopsys tool. We are going for ICC tool. So you have to install the tool. So they will provide some project. So we have to follow according that. VNC
When
is
the
like
placements will start, ma'am?
placement that I was not aware. So, but because you have to understand all these things now.
Okay, ma'am. And if anyone helping to make a resume for our physical design engineer, can you please help us to how to make that for separate for us only for physical design engineers?
No, Ali, don't worry. Actually, they will only help us. Recording is there? Let me stop recording, Ali, because I'm talking in Telugu now. Oh, Saira is not there. I can't stop that recording. Okay, so generally these so once we'll finish this first we had to finish the tool. Okay, so you had to practice more the tool. So what, suppose if I say to do one flow plan, now you do one flow plan, but your timing is not fixed and you see lot of congestion, then what you had to do, right? You had to redo flow plan and you had to come to the route again. This way you had to do multiple iterations, so you had to